students, welcome to ninth standard Navodaya entrance examination class. So today we discuss what are the questions that asked in light chapter. So you are all studied this light chapter in 6th, 7th and also in 8th standard. What is light? What is light? Light is a form of energy. If the light falls on object, that reflects. The reflected rays falls on our eyes, and that image is formed in retina part. Then we can identify what is that object. That means the sensation of vision is called light. So light is a form of energy. So the sensation of vision is called light. In this light, we understood the certain concepts. One is the reflection of light. What is a reflection of light? What is a reflection of light? It's a plane surface, highly polished plane surface. Imagine that we can take a mirror or a highly polished plane surface. If the ray of light it falls on this object, it reflects. So rebouncing of light is called reflection of light. So when a ray of light it falls on highly polished plane surface, it reflects or it rebounds. So the phenomenon of the rebouncing of light when it falls on highly polished plane surface is called reflection of light. So the ray of light, it passes or it falls on the plane surface. This ray is called incident ray. This is the plane surface. This incident ray, where it touches the plane surface, or the incident ray where it falls on the plane surface, that point is called point of incidence. Then, when this incident ray it falls on this point, from this point it reflects. This ray is called a reflected ray. So, the phenomenon of rebouncing of light when it falls on highly polished plane surface is called reflection. The ray of light, it falls on the surface. That ray is called incident ray. After it touches the plane surface, it reflects. That ray is called a reflected ray. So AB is the incident ray. It touches at a point O, that is called point of incidence. From this point of incidence, it reflects. That ray is called a reflected ray. From this point of incident, we draw a perpendicular line to the plane. This is called normal ray. So, the incident ray the reflected ray and normal to the plane at the point of incidence all lie on the same plane. This is known as first law of reflection. So, the incident ray, the reflected ray, normal to the plane at the point of incidence all lie on the same plane. Incident ray, reflected ray, normal ray, point of incidence ಮೇಲೆ ಏನಾಗ್ತಿಲ್ಲ ಒಂದೇ ಒಂದು ಪ್ಲೇನ್ ಮೇಲೆ ಪಾಸ್ ಆಗುತ್ತೆ. This is first law of incidence, reflection. So, the incident ray, the reflected ray, normal to the plane at the point of incidence all lie on the same plane. This is first law of reflection. The angle between the incidence ray to the normal is called angle of incidence. It is denoted by the symbol I. So, the angle between the incident ray and normal to the plane is known as angle of incidence. It is denoted by I. The angle between the normal to the reflected ray is called angle of reflection. It is denoted by angle R. So the angle of incidence is equal to the angle of reflection. This is second law of reflection. So the angle of incidence is equal to the angle of reflection. Suppose if angle of incidence is 30 degree, what is the angle of reflection? It is also 30 degree. These two statements are known as laws of reflection. So what is reflection of light? The phenomenon of rebouncing of light when it falls on highly polished plane surface is called reflection of light. So laws of reflection, the incident ray, the reflected ray and normal to the plane at the point of incidence all lie on the same plane. So the angle of incidence is equal to angle of reflection. These are the important laws of reflection. All these points are very important. Based on this, we ask some questions. See, this is the plane surface. The number of rays it falls on this plane surface, they reflect. It's called regular reflection. So it is curved surface or curved plane surface, irregular surface. If the rays of light it falls on this irregular surface, they also reflect. It is called irregular reflection. Okay. So the first point we have to know what is light. So light is a form of energy that enable us to see. All objects reflects the light rays that falls on it. These reflected rays, when received by our eyes, make the objects visible to us. We are able to see through the transparent medium as light is transmitted through it. The speed of light in vacuum is 3 into 10 to the power of 8 meter per second. So what are the important facts that are related to this light? This is reflection of light, incident ray, the reflected ray, angle of incidence, angle of reflection and normal to the plane or the terms that are related to the reflect light. So what is incident ray? The ray of light which falls on the mirror or smooth surface is called incident ray. What is reflected ray? The ray of light which is sent back by the mirror is known as a reflected ray. So point of incidence. So the point at which the incident ray falls on the mirror is called point of incidence. What is normal ray? The normal is a line at right angle to the mirror surface at the point of incidence. So what is angle of incidence? The angle made by the incident ray with the normal at the point of incidence is called angle of incidence. So the angle made by the reflected ray with the normal at the point of incidence is called angle of reflection. So what is reflection of light? The phenomenon of bouncing back of light rays in the same medium on striking a smooth surface is called reflection of light. This is the geometrical picture of the phenomenon of the reflection of light. So what are the laws of reflection? There are two important laws. The first law is the incident ray, the reflected ray and the normal at the point of incidence all lie on the same plane. So the angle of incidence is equal to the angle of reflection. This is the second law of reflection. So we get the reflecting surface of the mirror, we can coat on another part of that mirror by silver. So the metal is, silver metal is one of the best reflection of light. So silver mirror one side ನಾವು ಏನು ಮಾಡ್ತೀವಿ ಕೋಟ್ ಮಾಡ್ತೀವಿ, ಮತ್ತೊಂದು ಪಾರ್ಟ್ ಏನಾಗುತ್ತೆ ray of light ಬಿದ್ದಾಗ ರಿಫ್ಲೆಕ್ಟ್ ಆಗುತ್ತೆ, ರಿಬೌನ್ಸ್ ಆಗುತ್ತೆ. So a ray of light which is incident normally on a mirror is reflected back along its own path. These are all the important. So regular and irregular reflections of light. In that process, the first point is when a beam of incident light is reflected as a parallel beam is one direction, if regular reflections of light takes place from a smooth surface. So regular reflection taking place only in the smooth surface. A highly polished metal surface, polished wooden table and still water surface produces regular reflections. So where we get this regular reflection? A highly polished metal surface, polished wooden table and still water surface, ನಿಂತಿರ್ತಕ್ಕಂಥ ನೀರು, still water surface, not moving water surface, still water surface produces regular reflections. So irregular reflection or diffused reflection takes place through a rough surface. So reflection through cardboard, paper, table, walls, unpolished metal objects, etc. are the examples of irregular reflections or diffused reflections. A book lying on the table can be observed by us due to diffuse reflection or irregular reflection of light falling on the book. ಒಂದು ಟೇಬಲ್ ಮೇಲೆ ನಾವು ಬುಕ್ಕನ್ನು ಇಡ್ತೀವಿ, ಹೈಲಿ ಪಾಲಿಶ್ ಮೇಲೆ ಬುಕ್ ಇಟ್ಟಾಗ ಏನಾಗುತ್ತೆ, ಅದು ಸ್ವಲ್ಪ ಆದ ಇರ್ರೆಗ್ಯುಲರ್ ರಿಫ್ಲೆಕ್ಷನ್ ಆರ್ ಡಿಫ್ಯೂಸ್ಡ್ ರಿಫ್ಲೆಕ್ಷನ್ಗೆ ಎಕ್ಸಾಂಪಲ್ ಆಗುತ್ತೆ. ಸೊ ವಾಟ್ ಇಸ್ ಮಲ್ಟಿಪಲ್ ರಿಫ್ಲೆಕ್ಷನ್ಸ್? See, you can take the two mirrors, we have to kept each perpendicular to each other. We kept an object. We can observe the multiple number of reflections in the another part of the mirror. Such reflections are called multiple reflections. So what is multiple reflection? So the reflection of light back and forth several times between reflecting surfaces is called multiple reflections. So what is multiple images? When two plane mirrors are placed at the angle, then multiple images of an object are formed when the object is placed between the two plane mirrors. So the number of images formed is given by the formula 360 divided by theta minus 1. Since theta means it is an angle 180 degree, 120 degree, 90 degree, 60 degree, 45 degree or 0 degree. So these are all the concepts that are there in reflection of light. Then what is mirror? What is mirror? A mirror is a highly polished plane surface. One of its face is painted with the silver. Okay? So mirror. What is mirror? A mirror is a polished surface like glass which reflects almost all the light that are incident on it. So a mirror is a plain surface. It is just like a glass. Okay. If the ray of light it falls on it, all the incident rays that reflects, almost all the incident rays that reflects back. Such a object is called a mirror. So a mirror is a polished surface like glass which reflects almost all the light that is incident on it. In that mirror there are two types. One is the plane mirror and another one is the spherical mirror. So what is plane mirror? If the reflecting surface of a mirror is plane, if the reflecting surface of a mirror is plane, it is called plane mirror. Image formed by plane mirrors can be seen only by looking into the mirror. Image formed by plane mirrors has the following properties. So, ನಾವು ನೋಡಿದ್ರಿ ಗ್ಲಾಸ್ ನೋಡ್ತೀವಿ, ನಮ್ಮ ಮನೆ ಮುಂದೆ ಮಿರರ್ ಇರುತ್ತೆ, ಆ ಮಿರರ್ ಮುಂದೆ ನಾವು ನಿಂತ್ಕೊಂಡು ನೋಡ್ತೀವಿ, ನಿಂತ್ಕೊಂಡು ನಮ್ಮ ಇಮೇಜ್ ಏನಾಗುತ್ತೆ ನೀಟಾಗಿ ಕಾಣಿಸ್ತಾ ಇದೆ. ಅದೇನಾಗಿದೆ, ಮಿರರ್ ಇಟ್ ಇಸ್ ಪ್ಲೇನ್ ಸರ್ಫೇಸ್. ಸೊ ದ ಇಮೇಜ್ ಫಾರ್ಮ್ಡ್ ಬೈ ದ ಪ್ಲೇನ್ ಸರ್ಫೇಸ್ ಇಸ್ ಕಾಲ್ಡ್ ಪ್ಲೇನ್ ಮಿರರ್. In mirror, two types. One is the plane mirror. Okay. What are the properties of this plane mirror? See, it is always virtual and erect. The size of the image is equal to the size of the object. The image formed is as far behind the mirror as the object is in front of it. The image is laterally inverted, that is, left seems be right and right seems be left. So ನಮ್ಮ left side right side ಗೆ ಕಾಣಿಸುತ್ತೆ, right side left side ಗೆ ಕಾಣಿಸುತ್ತೆ. That is lateral reflection ಅಂತ ಹೇಳಿ ಹೇಳ್ತೀವಿ ಅದನ್ನ. So what are the uses of plane mirrors? So plane mirrors are commonly used as looking glass because the reflection that forms the image is always erect and laterally inverted, but they are always virtual. Plane mirrors are used in making periscopes, which is used in submarines. ಪೆರಿಸ್ಕೋಪ್ಸ್ ನಾವು ಪ್ರಿಪೇರ್ ಮಾಡಲಿಕ್ಕೆ ನಾವೇನು ಮಾಡ್ತೀವಿ, ಈ ಪ್ಲೇನ್ ಮಿರರ್ಸನ್ನು ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಸೊ ಪ್ಲೇನ್ ಮಿರರ್ಸ್ ಆರ್ ಯೂಸ್ಡ್ ಆಸ್ ಬ್ಲೈಂಡ್ ಟರ್ನ್ಸ್ ಆಫ್ ಸಮ್ ಬ್ಯುಸಿ ರೋಡ್ಸ್ ಟು ಸಿ ದ ವೆಹಿಕಲ್ಸ್ ಕಮಿಂಗ್ ಫ್ರಮ್ ಅದರ್ ಸೈಡ್ಸ್. ದೇ ಆರ್ ಯೂಸ್ಡ್ ಟು ಮೇಕ್ kaleidoscope, a toy which is produced beautiful pattern from colored paper pieces of glass or some colored bead heads. So what are the uses of plane mirrors? Plane mirrors are commonly used as looking glass because the reflection that forms the image is always erect and laterally inverted, but they are always virtual. It is used in making periscopes. Periscopes are used in submarines. It is used as blind turns of some busy roads to see the vehicles coming from the other side. They are used to make a kaleidoscope, a toy which is produces beautiful pattern from colored pattern paper, pieces of glasses or some colored beads. Then another type is that is spherical mirror. What is spherical mirror? It is a mirror, it is obtained by the sphericals. So the surface of the mirror is in spherical shape is called spherical mirror. So one is the plane mirror, this is the plane surface. We obtain the image by the plane surface. It is a spherical shape. The mirror is in spherical form. Such a mirrors are the mirrors obtained by the sphericals are called spherical mirrors. It is the spherical shape. Spherical surface. It is the plane surface. So the reflecting surface of the mirror is spherical, is called spherical mirror. The reflecting surface of the mirror is plane surface, is called plane mirror. In this spherical mirrors, again there are two types. One is if the reflecting surface of the spherical mirror is inwards, it is a silver coated part. This is the reflecting surface. The reflecting surface of the mirror is inwards. Such a spherical mirror is called concave mirror. If the reflecting surface of the mirror is outwards, this is the reflecting surface. If the reflecting surface of the mirror is outwards, such a mirror is called convex mirror. So the mirrors, if the reflecting surface is in spherical, or the reflecting surface of a mirror is spherical, is called spherical mirror. Again, in that spherical mirror there are two types. One is concave mirror, another one is convex mirror. If the reflecting surface is inwards of the spherical mirror, is called concave mirror. If the reflecting surface of a spherical mirror is outwards, such a mirror is called convex mirror. So these are all the two types of spherical mirrors. So in that mirror there are two types. One is the plane mirror and another one is spherical mirror. So in this spherical mirror, again there are two types. One is the concave mirror and another one is convex mirror. Okay. Then, so based on that, we have to see what are spherical mirrors. If the reflecting surface of a mirror is spherical, then the mirror is called spherical mirror. So again in that spherical mirror there are two types. One is the concave mirror, the spherical mirror which inwards curve reflecting surface. So the spherical mirror with inward curve reflecting surface is called concave mirror. So in concave mirror, the image formed depends on the distance of the object from the pole of the concave mirror. What is pole? See, this is the point. The central part of the concave mirror is called pole. If the ray of light or incident ray it falls at that point, again it reflects in the same direction. When the ray of light it falls on a concave mirror or convex mirror, from that point it again rebounds in the same direction. That point is called pole of the mirror. The central part of the spherical mirror is called center of curvature. It is denoted by the symbol C. This is the pole of the mirror. This is the pole of the concave mirror. This is the pole of the convex mirror. If the ray of light it falls on this point, again it rebounds in the same direction. So incident ray and reflected ray both are coincide. From that point is called pole of the mirror. In this concave mirror, if we kept an object at any point from the pole, again we get the image of this object is in front of this concave mirror. In case of convex mirror, we obtain the image of the object behind the mirror. Convex mirror ಅಲ್ಲಿ ಇಮೇಜ್ ಫಾರ್ಮೇಷನ್ ಆಗ್ತಕ್ಕಂಥದ್ದು ಆ ಮಿರರ್ನ ಹಿಂಭಾಗದಲ್ಲಾಗುತ್ತೆ. ಅದೇ ಕಾನ್ಕೇವ್ ಮಿರರ್ ಅಲ್ಲಿ ಅದರ ಇಮೇಜಸ್ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಆ ಆಬ್ಜೆಕ್ಟ್ನ ಮುಂಭಾಗದಲ್ಲಿ ರಿಫ್ಲೆಕ್ಟಿಂಗ್ ಸರ್ಫೇಸ್ನ ಮುಂಭಾಗದಲ್ಲಿ ಏನಾಗುತ್ತೆ ಇಮೇಜ್ ಫಾರ್ಮೇಷನ್ ಆಗುತ್ತೆ. ಇನ್ ಫ್ರಂಟ್ ಆಫ್ ದ ಮಿರರ್ ದಟ್ ಇಮೇಜಸ್ ಆರ್ ಫಾರ್ಮ್ಡ್ ಇನ್ ಕಾನ್ಕೇವ್ ಮಿರರ್. Okay, so the image formed by concave mirror depends on the distance of the object from the pole of a concave mirror. So object ಅನ್ನು ನಾವು ಆ ಪೋಲ್ ಇಂದ ಎಷ್ಟು ಡಿಸ್ಟೆನ್ಸ್ ಅಲ್ಲಿ ಇಟ್ಟಿದೀವಿ ಅನ್ನೋದ್ರ ಮೇಲೆ ಇಮೇಜ್ ಫಾರ್ಮೇಷನ್ ಆಗ್ತಕ್ಕಂಥದ್ದು ಡಿಪೆಂಡ್ ಆಗಿರುತ್ತೆ. ಯಾವುದಲ್ಲಿ ಕಾನ್ಕೇವ್ ಮಿರರ್ ಅಲ್ಲಿ. Convex mirror. What is convex mirror? The spherical mirror with outward curve reflecting surface is called convex mirror. So the spherical mirror with outward curve reflecting surface. Outward curve reflecting surface containing spherical mirrors are called convex mirrors. So the image formed by convex mirror is always virtual, erect and smaller than the object. That is the diminished ಅಂತ ಹೇಳಿ. ಸೊ ಇಮೇಜ್ ಫಾರ್ಮೇಷನ್ ಆಗ್ತಕ್ಕಂಥದ್ದು ಕಾನ್ವೆಕ್ಸ್ ಮಿರರ್ ಯಾವತ್ತು ಆಬ್ಜೆಕ್ಟ್ ಏನಿರುತ್ತೋ ಅದಕ್ಕಿಂತ ಚಿಕ್ಕದಾಗಿ ಇರುತ್ತೆ, ದೊಡ್ಡದಾಗಿರಲ್ಲ. ಸೊ ವಾಟ್ ಆರ್ ದ ಯೂಸಸ್ ಆಫ್ ಕಾನ್ಕೇವ್ ಮಿರರ್ ಅಂಡ್ ಕಾನ್ವೆಕ್ಸ್ ಮಿರರ್? ಟು ಸಿ ದ ಲಾರ್ಜ್ ಇಮೇಜಸ್ ಆಫ್ ಟೀತ್ ಆಫ್ ಪೇಷಂಟ್ಸ್, ಕಾನ್ಕೇವ್ ಮಿರರ್ಸ್ ಆರ್ ಯೂಸ್ಡ್ ಬೈ ಡೆಂಟಿಸ್ಟ್. ಸೊ ನಮ್ಮ ಹಲ್ಲಲ್ಲಿ ಏನಾದರೂ ಕ್ಯಾವಿಟಿ ಆಯಿತು, ಇರೋದು ಪ್ರಾಬ್ಲಮ್ ಆಯಿತು ಅಂದರೆ ಆ ಎಲ್ಲಿ ಪ್ರಾಬ್ಲಮ್ ಆಗಿದೆ, ಯಾವ ಪಾರ್ಟಲ್ಲಿ ಡ್ಯಾಮೇಜ್ ಆಗಿದೆ ಅಂತ ಐಡೆಂಟಿಫೈ ಮಾಡಲಿಕ್ಕೆ ಈ ಕಾನ್ಕೇವ್ ಮಿರರನ್ನು ಡೆಂಟಿಸ್ಟ್ ಯೂಸ್ ಮಾಡ್ತಾರೆ. ಸೊ ಟು ಸಿ ದ ಲಾರ್ಜ್ ಇಮೇಜ್ ಆಫ್ ಟೀತ್ ಆಫ್ ಪೇಷಂಟ್, ಕಾನ್ಕೇವ್ ಮಿರರ್ಸ್ ಆರ್ ಯೂಸ್ಡ್ ಬೈ ಡೆಂಟಿಸ್ಟ್. ಇನ್ ಟಾರ್ಚಸ್, headlights of vehicles and searchlights, to get a strong straight beam of light etc., concave mirrors are used as reflectors. So concave mirrors na reflectors ಆಗಿ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಯಾವುದಲ್ಲಿ? ಟಾರ್ಚ್ ಅಲ್ಲಿ, ಹೆಡ್ಲೈಟ್ಸ್ ಆಫ್ ವೆಹಿಕಲ್ಸ್ ಅಲ್ಲಿ ಅಂಡ್ ಸರ್ಚ್ ಲೈಟ್ಸ್ ಅಲ್ಲಿ. ಸ್ಟ್ರಾಂಗ್ ಸ್ಟ್ರೈಟ್ ಲೈಟ್ ಬೀಮ್ ಅನ್ನು ನೋಡಲಿಕ್ಕೆ ನಾವೇನು ಮಾಡ್ತೀವಿ, ಈ ಕಾನ್ಕೇವ್ ಮಿರರ್ಸ್ ಇವುಗಳಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಸೊ ಇನ್ ಟಾರ್ಚ್, ಹೆಡ್ಲೈಟ್ಸ್ ಆಫ್ ವೆಹಿಕಲ್ಸ್ and searchlights, to get a strong straight beam of light etc., concave mirrors are used. To see a large image of a face, then concave mirrors are used as shaving mirrors. So concave mirrors are used as the shaving mirrors. Concave mirrors are used dentists. Then concave mirrors are used in torches, headlights of vehicles, searchlights. In these cases we have to use this concave mirrors. So to see the traffic aid at the roadside or backside on the road, convex mirrors are used as rear view mirrors or side view mirrors in vehicles such as car, scooter, buses. Car, scooter, buses ಅಲ್ಲಿ ಬ್ಯಾಕ್ ಸೈಡ್ ಇಂದ ಬರ್ತಕ್ಕಂಥ ವೆಹಿಕಲ್ಸ್ ಎಷ್ಟು ಡಿಸ್ಟೆನ್ಸ್ ಬರ್ತಾ ಇದೆ, ಹೇಗಿದೆ ಅಂತ ಯೂಸ್ ಮಾಡಲಿಕ್ಕೆ ನಾವು ಕಾನ್ವೆಕ್ಸ್ ಮಿರರ್ಸ್ ಅನ್ನು ಯೂಸ್ ಮಾಡ್ತೀವಿ. So to see the traffic at the rear side or back side on the road, convex mirrors are used as rear view mirror or side view mirror in vehicles such as car, scooter and buses. Big convex mirrors are used as shop security mirrors. By installing a convex mirror in a shop, the shop owner can keep an eye on the customers. ಸೊ ನಾವು ಮಾಲ್ಗಳಲ್ಲಿ ನೋಡ್ತೀವಿ, ಮಾಲಲ್ಲಿ ನೋಡಿದಾಗ ಏನಾಗುತ್ತೆ, ಈ ಕಾನ್ವೆಕ್ಸ್ ಮಿರರನ್ನು ಯೂಸ್ ಮಾಡಿರ್ತಾರೆ. ಅಲ್ಲಿ ಶಾಪ್ ಓನರ್ ಯೂಸ್ ಮಾಡಿ ಕಸ್ಟಮರ್ಸ್ ಯಾವ ಥರ ಅಲ್ಲಿ ಏನೇನು ಮಾಡ್ತಾ ಇದ್ದಾರೆ, ಏನೇನು ಆಬ್ಜೆಕ್ಟ್ಸನ್ನು ತಗೋತಾ ಇದ್ದಾರೆ, ಅದನ್ನು ನೀಟಾಗಿ ಏನು ಮಾಡ್ತಿದ್ದಾರೆ ಸೂಪರ್ವಿಷನ್ ಮಾಡಲಿಕ್ಕೆ ಅದನ್ನು ಅವರು ಯೂಸ್ ಮಾಡ್ತಾರೆ. ಸೊ ಬಿಗ್ ಕಾನ್ವೆಕ್ಸ್ ಮಿರರ್ಸ್ ಆರ್ ಯೂಸ್ಡ್ ಆಸ್ ಅ ಶಾಪ್ ಸೆಕ್ಯೂರಿಟಿ ಮಿರರ್ಸ್. ಬೈ ಇನ್ಸ್ಟಾಲಿಂಗ್ ಎ ಕಾನ್ವೆಕ್ಸ್ ಮಿರರ್ ಇನ್ ದ ಶಾಪ್, the shop owner can keep an eye on the customers. So these are all the important facts that are comes in the mirror. So one more concept that in this, that is refraction of light. So what is light? A light is a form of energy. The sensation of vision is called light. That light we can understood what is a reflection of light. So the phenomenon of rebouncing of light when it falls on highly polished plane surface is called reflection of light. So laws of reflection. So the incident ray, the reflected ray and the normal to the plane at the point of incidence all lie on the same plane. The angle of incidence is equal to the angle of reflection. Then what is mirror? A mirror is a plane surface, all the rays falling on it, all those incident rays that reflects. Again, in that mirror there are two types. One is the plane mirror and another one is spherical mirror. A mirror whose reflecting surface is plane is called plane mirror. A mirror whose reflecting surface is spherical is called spherical mirror. Again, in that spherical mirror there are two types. One is the concave mirror and another one is convex mirror. A reflecting surface of a spherical mirror is inwards, is called concave mirror. A reflecting surface of a spherical mirror is outwards, it is called convex mirror. So convex mirrors are used in vehicles to see the vehicles that are coming from the back side. These mirrors are used in dentists. Concave mirrors are used in dentists to see the large images of the teeth. It is used in the searchlights and they are also used in certain materials. Shaving mirrors again is no use now. So these are the important concept that comes in this mirror. Then next concept is what is the refraction of light. What is refraction of light? See, this is the glass slab, rectangular glass slab ABCD. ABCD is a rectangular glass. The media which is present inside this glass is called glass medium. The media, outer surface of this glass media is called air medium. When the ray of light, it falls on the surface of this glass, it does not move in the same direction like this. So it bends and it bends in glass media, again it moves in the same direction in air media. This phenomenon is called refraction of light. When the ray of light, it travels from one medium to another medium, it changes its direction, or the bending up of a ray of light when it travels from one medium to another medium is called refraction of light. So the ray which is coming from the air media, this ray is called incident ray. It touches on the surface of this glass medium. From that point it bends or it changes its direction. This ray is called refracted ray. Again, refracted ray, it travels from glass medium to air medium. Again it changes its direction or it bends as in case of incident ray. So this incident ray and this ray, these two are parallel to each other. This ray is called emergent ray. So this is incident ray, this is the refracted ray and this one is the emergent ray. This incident ray, where it falls or where it touches the glass media, That point is called point of incidence. It is denoted by the symbol O. From this point we draw a normal perpendicular to the glass. This is called normal ray. So the phenomenon of bending up of a light when it travels from one medium to another medium is called refraction of light. So the incident ray, the refracted ray and the normal at the point of incidence all lie on the same plane. This is known as first law of refraction. The angle between the incident ray and the normal at the point of incidence is called angle of incidence. It is denoted by I. So the angle between the refracted ray and the normal line at the point of incidence is called angle of refraction. It is denoted by angle R. So the ratio between the sine of the angle of incidence to the sine of the angle of refraction is always a constant. That is sine I divided by sine R is constant. Sine is a trigonometric function. Sine of the angle of incidence. There are 6 trigonometric functions: sine, cos, tan, secant, cosecant and cotangent. That is cot. Sine, cos, tan, cot, secant, cosecant. These are all the 6 trigonometric functions. So apart from that, we can take only there is sine. So the ratio between the sine of the angle of incidence to the sine of the angle of refraction is a constant. This is known as second law of refraction. It was given by the famous physicist Snell. Hence, this second law of refraction is called Snell's law. The sine of the angle of incidence to the sine of the angle of refraction is always a constant. That constant is called refractive index. It is denoted by the symbol N. So refractive index of glass media with respect to air media is denoted by NGR. So refractive index of a medium glass to the medium air is denoted by NGR. So the refractive index of the glass medium with respect to air media is denoted by NAR. G glass, A stands air. Here air and glass. So the refractive index of glass media with respect to air is known as by NAG. The refractive index of air media with respect to glass media is denoted by GA, which is equal to the refractive index, that is speed of light in A divided by speed of light in glass. This ratio is known as refractive index. So the refractive index or the speed of light in vacuum with respect to the speed of light in a medium is known as a refractive index. It is also known as absolute refractive index. ಸೊ ಏರ್ ಮೂಲಕ ಬಂದಿದ್ದ ಲೈಟ್ ಅಲ್ಲಿ ಬರ್ತಕ್ಕಂಥ ಅದರ ಸ್ಪೀಡು ಮತ್ತೆ ಇನ್ನೊಂದು ಮೀಡಿಯಾದಲ್ಲಿ ಮೂವ್ ಆಗ್ತಕ್ಕಂಥ ಸ್ಪೀಡು ಅವೆರಡಕ್ಕೂ ಇರ್ತಕ್ಕಂಥ ರೇಷಿಯೋಗೆ ನಾವು ಏನು ಕರಿತೀವಿ ರಿಫ್ರಾಕ್ಟಿವ್ ಇಂಡೆಕ್ಸ್ ಅಂತ ಹೇಳಿ ಕರಿತೀವಿ. ಇನ್ ಸಿಂಬಾಲಿಕಲಿ ಇಟ್ ಇಸ್ ಡಿನೋಟೆಡ್ ಬೈ N12, which is nothing but refractive index of medium 2 divided by the speed of light in medium 1. So this is the speed of light in medium 2 with respect to the speed of light in medium 1. This is known as refractive index. Understand? So what is refraction of light? The phenomenon of bending up of a light when it travels from one medium to another medium is called refraction. So laws of refraction, the incident ray, the refracted ray and the normal to the plane at the point of incidence all lie on the same plane. The ratio between the sine of the angle of incidence to the sine of the angle of refraction is constant. This is known as second law of refraction. So these are the points that are very important in this refraction of light. So what is refraction of light? Change in path of a light ray as it passes from one medium to another medium is called refraction of light. A medium in which the speed of light is more is known as optically rarer medium. Here, this is the air media. This air media is called a rarer medium. This is the glass media. This is called a denser medium. So air media is the rarer medium and glass medium is known as a denser medium. Okay. So a medium in which the speed of light is more is known as optically rarer medium, and in which the speed of light is lesser is known as optically denser medium. Air medium anna rarer medium anta kariತೀವಿ, glass medium anna denser medium anta ತಗೋತೀವಿ. Suppose if we take water medium, it is called what? Denser medium. So the bottom, what we have to observe in this refraction of, give some examples. ಒಂದು ಬೀಕರಲ್ಲಿ ನೀವು ಒಂದು ನಿಂಬೆಹಣ್ಣನ್ನ ಇಡ್ತೀರ, ಆ ನಿಂಬೆಹಣ್ಣು ಇಟ್ಟು ನೋಡಿದಾಗ ಏನಾಗುತ್ತೆ, ಅದು ಒರಿಜಿನಲ್ ಶೇಪಿನ ಸ್ವಲ್ಪ ದೊಡ್ಡದಾಗಿ ಕಾಣಿಸುತ್ತೆ. ಒಂದು ಬೌಲಲ್ಲಿ ಒಂದು ಬೀಕರಲ್ಲಿ ನೀವು ಕಾಯಿನನ್ನು ಇಟ್ಟಾಗ ಅದು ಮೇಲೆ ಬಂದಾಗುತ್ತೆ. ಒಂದು ಸ್ಟಿಕ್ಕನ್ನು ನೀವು ಒಂದು ವಾಟ್ರಲ್ಲಿ ಬೆಂಡ್ ಮಾಡಿ ಇಟ್ಟಾಗ ಅದೇನಾಗುತ್ತೆ, ಆ ವಾಟರ್ ಬಾಟಮ್ ಇಂದ ಕೆಳಗಿಂತದ್ದು ಬೆಂಡ್ ಆಗಿರೋ ಥರ ಕಾಣಿಸುತ್ತೆ. So these are all the examples of this refraction of light. So the bottom of a pool containing water appears to be raised due to refraction of light, which takes place when the light rays passes from the pole of the water into air. So light rays the pole of the water in the air media ಗೆ ಬರ್ತಾ ಇದೆ. So denser medium ಇಂದ rarer medium ಕಡೆಗೆ light rays pass ಆಗ್ತದೆ ನಮ್ಗೆ ಆ ಥರ ಕಾಣಿಸುತ್ತೆ. So the letter appears to be raised when viewed through a glass slab placed over the document because of refraction of light. ಒಂದು ಲೆಟರ್ಸ್ ಅನ್ನು ಬರೆದು ಒಂದು ಗ್ಲಾಸ್ ಅನ್ನು ಅದ್ರ ಮೇಲೆ ಇಟ್ಟು ನೋಡಿದಾಗ ಏನಾಗುತ್ತೆ, ಆ ಲೆಟರ್ಸ್ ಮೇಲಕ್ಕೆ ಎದ್ದಿರೋ ಥರ ನಮಗೆ ಕಾಣಿಸುತ್ತೆ, ಬಿಕಾಸ್ ಆಫ್ ರಿಫ್ರಾಕ್ಷನ್ ಆಫ್ ಲೈಟ್. A pencil partially immersed in water appears to be bent because the refraction of light coming from the part of the pencil that is under water. A lemon kept in water in a glass tumbler appears to be bigger than its actual size when viewed from the sides. ಸೊ ಒಂದು ಟಮ್ಲರ್ಲಿ ನಾವು ನಿಂಬೆಹಣ್ಣು ಇಟ್ಟು ನೋಡಿದಾಗ ಅದು ಒರಿಜಿನಲ್ ಸೈಜ್ನ ಸ್ವಲ್ಪ ಇನ್ನು ದೊಡ್ಡದಾಗಿ ಕಾಣಿಸುತ್ತೆ. ಒಂದು ಕಾಯಿನನ್ನು ಇಟ್ಟು ಏನಾಗುತ್ತೆ, ಕಾಯಿನ್ ಕೂಡ ಮೇಲಕ್ಕೆ ಬಂದಿರೋ ಥರ ಕಾಣಿಸುತ್ತೆ, ಬಿಕಾಸ್ ಆಫ್ ರಿಫ್ರಾಕ್ಷನ್ ಆಫ್ ಲೈಟ್. ಸೊ ದೀಸ್ ಆರ್ ಆಲ್ ದ ಎಕ್ಸಾಂಪಲ್ಸ್ ಆಫ್ ದ ರಿಫ್ರಾಕ್ಷನ್ಸ್ ಆಫ್ ಲೈಟ್. Understand? Then come to the next point, that is lens. What is lens? See, this is the spherical mirror. This is another spherical mirror. This is the part of the first spherical mirror. This is the part of the second spherical mirror. We get an object. This is known as mirror. This is known as lens. So a lens is a piece of transparent glass bounded by two spherical surfaces. So lenses are transparent so that light can pass through. Lenses are mainly of two categories. This is the spherical mirror. This is the spherical mirror. See, this lens is a transparent medium. It is obtained by the part of the spherical mirrors. ಸೊ ಸ್ಪೆರಿಕಲ್ ಮಿರರ್ನ ಪಾರ್ಟನ್ನು ನಾವು ಒಂದ್ಕೊಂಡು ಜಾಯಿನ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, ಒಂದು ಟ್ರಾನ್ಸ್ಪರೆಂಟ್ ಮೀಡಿಯಾ ಸಿಗುತ್ತೆ. ದಟ್ ಟ್ರಾನ್ಸ್ಪರೆಂಟ್ ಮೀಡಿಯಾ ಈಸ್ ನೋನ್ ಆಸ್ ಲೆನ್ಸ್. In this lens there are two types. See, this is a lens obtained by the two spherical mirrors parts, or the parts of the two spherical mirrors that gives the lens. And these two are the spherical mirrors. Now I take these two parts, part of the first lens and part of the second spherical mirror, we get another lens. This is the reflecting surface. This reflecting surface is inwards of this spherical mirror. This is the reflecting surface, this is the reflecting surface of the other spherical mirror. If we take these two parts, we get a transparent glass medium that is known as lens. Here this is the reflecting surface is outwards of the one spherical mirror. This is the reflecting surface of the another spherical mirror. These two are known as the lens. This is convex lens. This is concave lens. It is a lens, or the convex lens is a lens. The central part is thick. Central part is a thick surface and the edges are thin. Concave lens is the lens whose the central part is thin and edges are thick. Okay. A convex lens is a lens in which the central part is thick and the edges are thin. A concave lens is a lens in which the central part is thin and the edges are thick. So central ಏನಾಗಿದೆ ತುಂಬಾ ತೆಳು ಇರುತ್ತೆ, thin ಆಗಿರುತ್ತೆ ಯಾವುದಲ್ಲಿ ಕಾನ್ಕೇವ್ ಲೆನ್ಸ್ ಅಲ್ಲಿ. ಅದೇ ಎಡ್ಜಸ್ ಏನಾಗಿರುತ್ತೆ thin ಆಗಿರುತ್ತೆ, ದಪ್ಪ ಇರುತ್ತೆ. ಇಲ್ಲಿ ಸೆಂಟ್ರಲ್ ಪಾರ್ಟ್ ದಪ್ಪ ಇರುತ್ತೆ, ಎಡ್ಜಸ್ ಏನಾಗುತ್ತೆ ತೆಳು ಇರುತ್ತೆ. So central part is thick and the edges are thin. Such a lens is known as convex lens. This is concave lens. It's simply convex lens or double convex lens or biconvex lens. This is double concave lens or biconcave lens, or simply we can say this is concave lens. So convex lens and concave lens are the two types of the lenses. Again in this convex lens there are different types. One face is the plane and another one is the convex. It is known as plano-convex lens. One is the concave part and another one is the convex part. This is known as concave-convex lens. Here one is the concave part and another one is the plane. This is plano-concave lens. So both surfaces are in concave shape. This is concave-convex lens. One is concave part and another one is convex lens. Concave-convex lens. Concave-concave lens, sorry, concave-convex lens. Plano-concave lens. Plano-convex lens and concave-convex lens are the types of the convex lenses and concave lenses. Okay. So what is lens? A lens is a plane or a transparent glass bounded by two spherical surfaces. So lenses are transparent so that light can pass through. Lenses are mainly two types. One is the convex lens and another one is concave lens. So convex lens is the lens which is thicker in the middle than at the edge. A beam of parallel rays of light falls on a convex lens from the left side. So image formed by convex lens are natural, and the nature and the size of the image formed by convex lens depends on the distance of the object from the convex lens. So concave lenses is the lenses in which thinner in the middle than at the edge. A parallel beam of light falls on the convex lens. After passing through the concave lens, the rays of light are diverging. So image formed by concave lenses is always virtual, erect and diminished. See, image formations ಅಂತನಲ್ಲಿ ಹೇಳ್ತಾ ಬಂದೆ. ಯಾವ ತರ image formation ಆಗುತ್ತೆ ಅಂತಂದ್ರೆ see, one is the convex lens. So this is the convex lens. This is the center. This is the ray of light passes through this central part of the lens. This central part of the lens is called optic center O. See here, this is focus F1. This is principal focus 2 F1. This is the focus F2. This is the principal focus to F2. When the ray of light it passes through the center of curvature to the optic center or the center of curvature, the line joining the centers of curvature of the two spherical mirror is known as principal axis. ಇದನ್ನ ಏನು ಕರೀತೀವಿ? Principal axis ಅಂತ ಕರೀತೀವಿ. But ಈ ಕಾನ್ಸೆಪ್ಟ್ ನಿಮಗೆ ಇಲ್ಲ, ಬಟ್ ಇಮೇಜ್ ಫಾರ್ಮೇಷನ್ ಮಾತ್ರ ಹೇಳ್ತಾ ಇದ್ದೀನಿ ಅಷ್ಟೇ. So this is an object AB. This object lies in between 2 F1 and F1. When the ray of light parallel to the principal axis are called secondary axis. If the ray of light is parallel to the principal axis, after the refraction it passes through the focus. So parallel principal axis ke parallel ಹೋಗಿದ್ದ ray ಏನಾಗುತ್ತೆ? It passes through the focus. Focus ಮೂಲಕ pass ಆಗುತ್ತೆ. The refracted ray. If the ray of light it passes through the optic center, it does not bend at any point, moves in a straight line. Optic center ಮೂಲಕ ray of light pass ಆಯಿತು ಅಂದ್ರೆ ಅದು ಎಲ್ಲೂ ಬೆಂಡ್ ಆಗಲ್ಲ, ಹಾಗೆ ಒಂದೇ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಸ್ಟ್ರೈಟ್ ಆಗಿ ಹೋಗುತ್ತೆ. This refracted ray and this ray, these two meet at the point. Then the image is formed here. This is A dash and B dash. It is the image. This is an object. This is an image. So in this convex lens, always we get the images depending upon the position of the object. Object ಅನ್ನು ನಾವು ಎಲ್ಲಿ ಇಟ್ಟಿದೀವಿ ಅನ್ನೋದ್ರ ಮೇಲೆ ಏನಾಗುತ್ತೆ ನಮಗೆ ಇಮೇಜ್ ಎಲ್ಲೆಲ್ಲಿ ಫಾರ್ಮ್ ಆಗುತ್ತೆ, ಅದರ ಸೈಜ್ ಏನಾಗಿರುತ್ತೆ ಅಂತ ಕಂಪ್ಲೀಟ್ ನಮಗೆ ಗೊತ್ತಾಗುತ್ತೆ. The concept. Okay. Suppose if we take a concave lens. This is concave lens. This is the optic center. This is the ray of light. This is known as principal axis. This is 2 F1. This is F1. This is F2. This one is 2 F2. When the ray of light it falls on the surface of the concave lens, again it diverges. It moves in the slide. It bends towards the base of the mirror. So this refracted ray coincide at a particular point. In this way, we get the position of the image if the object is kept at certain distance from the mirror, from the lens. Lens ಇಂದ ಎಷ್ಟು certain distance ಅಲ್ಲಿ ನಾವು ಇಟ್ಟಿರ್ತೀವಿ ಅನ್ನೋದ್ರ ಮೇಲೆ ಏನಾಗ್ತಾ ಇದೆ ಇಮೇಜ್ ಎಲ್ಲಿ ಫಾರ್ಮೇಷನ್ ಆಗುತ್ತೆ ಅಂತಕ್ಕಂಥದ್ದು ನಾವು ಇಲ್ಲಿ ಐಡೆಂಟಿಫೈ ಮಾಡ್ತೀವಿ. So in this convex lens, another name of this convex lens is called converging lens and very curving. So convex lens is also known as converging lens. Why convex lens is called converging lens? See, this is the convex lens. This is the principal axis. This is the optic center. If the rays of light parallel to the principal axis, they falls on this convex lens, these rays the refracted rays, they meet at a particular point on the principal axis. So number of rays falls ಆದರೆ ಕಾನ್ವೆಕ್ಸ್ ಲೆನ್ಸ್ ಮೇಲೆ ಬಿತ್ತು ಅಂದಾಗ ಆ ರಿಫ್ರಾಕ್ಟೆಡ್ ರೇಸ್ ಎಲ್ಲ ಏನಾಗುತ್ತೆ ಒಂದೇ ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಮೀಟ್ ಆಗುತ್ತೆ. Hence this convex lens is called converging lens. The beam of light rays parallel to the principal axis falls on the convex lens. They meet at a particular point. The refracted rays, they meet at a particular point. Hence this convex lens is called converging lens. See, in case of concave lens, this is the concave lens. This is the optic center. This is the principal axis. The beam of rays falls on the concave lens. The refracted rays, they diverge. Move ಆಗ್ತಾ ಇದೆ. ಈ ರಿಫ್ರಾಕ್ಟೆಡ್ ರೇಸ್ ಯಾವುದೇ ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಮೀಟ್ ಆಗ್ತಾ ಇಲ್ಲ. Hence this concave lens is called diverging lens. So concave lens is called diverging lens. Then after the refraction, the refracted rays, they meet at a particular point behind the mirror. They meet at this backward. In this case, they diverge. Hence, concave lens is called diverging lens and convex lens is called converging lens. So, in that lens, there are two types. One is concave lens and another one is convex lens. So, concave lens is a lens which is thinner. Okay, what are the uses of this concave lens? Concave lens is called concave lens is called diverging lens and convex lens is called converging lens. So, convex lens is the thin which is thicker in the middle than at the edge. A beam of parallel rays of light falls on a convex lens from the left side. So left side the beam of light rays move ಆಗುತ್ತೆ lens ಮೇಲೆ. Right side ಅಲ್ಲಿ they meet at a particular point. Hence this lens is called converging lens. The nature and size of the image formed by convex lens depends upon the distance of the object from the convex lens. ಈ convex lens ಎಷ್ಟು ದೂರದಲ್ಲಿ ನಾವು ಆಬ್ಜೆಕ್ಟ್ ಅನ್ನು ಇಟ್ಟಿದ್ದೀವಿ ಅನ್ನೋದ್ರ ಮೇಲೆ ಯಾವ ತರ ಇಮೇಜ್ ಫಾರ್ಮೇಷನ್ ಆಗುತ್ತೆ ಅಂತಕ್ಕಂಥದ್ದು ಡಿಪೆಂಡ್ ಆಗಿರುತ್ತೆ. So concave lens is a lens in which is thinner in the middle than at the edge. A parallel beam of light falls on a concave lens. After passing through the concave lens, the rays of light are diverging or spreading out. Those refracted rays does not meet at any point. Hence, the concave lens is called diverging lens. So the image formed by concave lens is always virtual, erect and diminished or highly small in size. So what are the uses of lens? So convex lenses are used as magnifying glass in the manufacturing spectacles, camera, microscope, telescope, binoculars. In these we have to use the convex lens. In order to see the image of the person standing outside, concave lenses are used in peephole in the door of hotel rooms. Concave lenses are used in making spectacles. So concave ಮತ್ತು convex ಎರಡನ್ನೂ ನಾವು ಏನು ಮಾಡ್ತೀವಿ spectacles ಅನ್ನು ನಾವು ಯೂಸ್ ಮಾಡ್ತೀವಿ. So these are the important facts about this lens. So next point is what is dispersion of light. What is dispersion? See, take a triangular prism. This is a prism. What is dispersion of light? ABC is a prism. Is that prism? When a white light or a composite light, it falls on the surface of this prism. This is white light. It falls on the surface of the prism. Again, it bends into, or it splits into 7 colors. So, a white light, it falls on the prism. It splits into 7 colors, that is violet, indigo, blue, green, yellow, orange, red. So the phenomenon of splitting up of a composite light or white light into its constituent colors by using a prism is called dispersion. So the phenomenon of splitting up of a composite light into its constituent colors using a prism is called dispersion of light. So in this dispersion of light, when a white light it falls on this prism, it splits into 7 colors, that is violet, indigo, blue, green, yellow, orange, red. It is known as Vidgaya, or it is known as a group of these 7 colors is called spectrum. A band of colors obtained from the white light when it falls on this prism is called spectrum. A band of colors is called spectrum. That spectrum consists of violet, indigo, blue, green, yellow, orange, red. Group in the spectrum. So the phenomenon of splitting up of a composite light or white light into its constituent colors by means of prism or using a prism is called dispersion. So a band of colors obtained from this dispersion process is known as spectrum. This spectrum consists of violet, indigo, blue, green, yellow, orange and red. This is known as dispersion of light. So when a white light ray passes through a transparent prism, then it splits into 7 colors. This phenomenon is known as dispersion of light. So the 7 colors are violet, indigo, blue, green, yellow, orange and red. So the deviation in the red color of light is minimum. So red color deviation is minimum. So red color ಏನಕ್ಕೆ ತುಂಬಾ ಕಡಿಮೆ deviate ಆಗ್ತಾ ಇದೆ, but the yellow violet color is maximum deviation. Maximum deviation ಆಗ್ತಾ ಇರತಕ್ಕಂತದ್ದು violet, minimum deviation ಆಗ್ತಾ ಇರತಕ್ಕಂತದ್ದು red. So the deviation in red color of light is minimum and in violet color of light is maximum. So red, green and blue are primary colors. So red, green, blue are called primary colors. So this is about the dispersion of light. So what is dispersion of light? So the phenomenon of splitting up of a composite light into its constituent colors is called dispersion. So to get this dispersion process, the prism is compulsory or it is must. If prism is not there, dispersion is not possible. So the phenomenon of splitting up of a composite light into its constituent colors using a prism is called a dispersion. When white light it falls on this prism, it splits into 7 colors, that is violet, indigo, blue, green, yellow, orange and red. So the band of all these 7 colors is called spectrum. So violet is maximum deviated and red color is the minimum deviation. ತುಂಬಾ ಜಾಸ್ತಿ ಬೆಂಡ್ ಆಗ್ತಕ್ಕಂಥದ್ದು violet, ಕಡಿಮೆ ಬೆಂಡ್ ಆಗ್ತಕ್ಕಂಥದ್ದು red. So red, blue and green are called primary colors. Understand? So these are the important facts that are there in this light chapter. So what is light? What we have to study in today's class? So what is the definition of light? Uses of light and then mirror, reflection of light, loss of reflection, then mirror. In that types of mirror, again in that mirror there are two types. One is the plane mirror and another one is spherical mirror. Again in that spherical mirror there are two categories. One is the concave mirror and another one is convex mirror. What are the uses of concave mirror and convex mirror? And you know the refraction of light, definition of refraction of light, loss of refraction of light, and lens, types of lens, uses concave lens and convex lens. Convex lens is called converging lens and concave lens is called diverging lens. What are the uses of convex and concave lens? And the dispersion phenomena, or dispersion of light and the spectrum of the light. All these concepts you have to discuss today. So based on all this, how they ask the questions in this part. Okay, understand? Now, come to the question. A beam of light striking the reflecting surface is called dash. Beam of light striking the reflecting surface is called dash. Options: reflecting rays, incident ray, refracted ray, normal ray. So beam of light striking the reflecting surface is called incident ray. So right answer is incident ray. What makes objects visible? Option: the absorption of light by objects, the reflected light from the object, the total internal reflection taking place in an object, the reflected light from the object. So, what makes objects visible? The reflected light from the object is the right answer. If the angle of incidence is 50 degree, then calculate the angle between the incident ray and reflected ray. See to that. This is the diagram of the refraction of light. This plane surface. This is incident ray. This is refracted ray. This is the normal. Okay. The angle of incidence is 50 degree. Angle of incidence is 50 degree. Then calculate the angle of incident ray and reflected ray. Angle of incidence 50 degree anta kodidare. Now we find the angle between the incident ray and the reflected ray. Illinda illige irtakanta angle ಎಷ್ಟಿದೆ ಅಂತ ಕೇಳಿದರೆ. So if the angle of incidence is 50 degree, then angle of reflection is also 50 degree. Because angle of incidence is equal to angle of reflection. Angle of incidence is 50 degree. What is the angle between the incident ray to reflected ray? ಇವೆರಡರ ಮಧ್ಯೆ ಇರತಕ್ಕಂಥ ಆಂಗಲ್ ಎಷ್ಟು ಅಂತ ಕೇಳಿದರೆ, ಹಾಗಾಗಿ ಇವೆರಡನ್ನ ಆಡ್ ಮಾಡಿದ್ರೆ ನಿಮಗೆ ಆನ್ಸರ್ ಸಿಗುತ್ತೆ. ದಟ್ ಇಸ್ 50 plus 50 100 degree. So if the angle of incidence is 50 degree, then calculate the angle between the incident ray and reflected ray. Options: 50 degree, 100 degree, 130 degree, 80 degree. So the answer is 100 degree. Dash refers to the collection of rays. A collection of rays is called beam. So dash refers to collection of rays. Options: photon, beam, shadow, image. Answer is beam. Which of the following travels faster? Jet aeroplane, sound, light, supersonic planes. So jet aeroplane, sound, light, supersonic plane. Which of the following travels faster? So light travels faster apart from these three. So correct answer is light. What makes the object visible? Size, time, color, light. So what makes the object visible? Light is the answer. An example of luminous object is dash, star, smooth surface, mirror, cloud. So example of luminous object is star. With what is glass coated in order to convert it is a mirror? With what is glass coated in order to convert it into a mirror? ಒಂದು ಗ್ಲಾಸ್ ಅನ್ನ ಮಿರರ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ ಅದಕ್ಕೆ ಏನನ್ನ ಕೋಟ್ ಮಾಡ್ತಾರೆ? ಒಂದು ಸೈಡು ಸಿಲ್ವರ್, ಕಾಪರ್, ಅಲ್ಯೂಮಿನಿಯಂ, ಪ್ಲಾಟಿನಮ್. ಸೊ ಸಿಲ್ವರ್ ಇಸ್ ದ ರೈಟ್ ಆನ್ಸರ್. How many images are obtained when a plane mirror are arranged parallel to each other? ಎರಡು ಪ್ಲೇನ್ ಮಿರರ್ ನ ಒಂದಕ್ಕೊಂದು ಪ್ಯಾರಲಲ್ ಆಗಿ ಅರೇಂಜ್ ಮಾಡಿದ್ವಿ ಅಂದಾಗ ಎಷ್ಟು ನಾವು ಇಮೇಜಸ್ ಅನ್ನ ಪಡಿತೀವಿ? How many images are obtained when plane mirrors are arranged parallel to each other? A single image, two image, infinite number of images, zero images. If the two plane mirrors are parallel to each other, then the images formed are not possible to count, that is, the infinite number of images are obtained. Angle of incidence is always dash. Angle of equal to angle of reflection, equal to angle of refraction, more than the angle of reflection, less than the angle of reflection. So the angle of incidence is always equal to angle of reflection. What is the phenomenon of light bouncing back in the same medium called? Reflection, refraction, dispersion, splitting. Reflection. Speed of light is fastest in air, water, diamond, glass. Air, because the speed of light in air is approximately equal to 3 into 10 to the power of 8 meter per second, because the speed of light in vacuum is almost same in air. Both are same. Minute or fraction part, it changes its speed. So the given option, speed of light is fastest in air. A smooth shining surface which rebounds the light back in the same or in different directions is called dash. A mirror, a lens, a reflection of light, point of incidence. A smooth shining surface which rebounds the light back in the same or in a different direction is called a mirror. In case of reflection of light, the angle of incidence and angle of reflection are related as I is equal to R, I is less than R, I is greater than R. No definite relation. So in case of reflection of light, angle of incidence and the angle of reflection are related as angle I is equal to angle R. I is equal to R is the right answer. What is the angle of incidence of ray if the reflected ray is at an angle of 90 degree to the incident? So ನೋಡಿ, ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಇರ್ತಕ್ಕಂಥ ಆಂಗಲ್ ಎಷ್ಟನ್ನು ಕೊಟ್ಟಿದ್ದವರು 90 ಡಿಗ್ರಿ ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ ಟೋಟಲ್. ಅರ್ಥ ಆಯ್ತಾ? ಸೊ ವಾಟ್ ಈಸ್ ದ ಆಂಗಲ್ ಆಫ್ ಇನ್ಸಿಡೆನ್ಸ್ ಆಫ್ ದ ರೇ? ಇದು ಎಷ್ಟಿರುತ್ತೆ ಅಂತ ಕೇಳಿದರೆ, ಆಂಗಲ್ ಆಫ್ ಇನ್ಸಿಡೆನ್ಸ್ ಎಷ್ಟು ಅಂತ ಕೇಳಿದ್ದಾರೆ. ಸೊ ಆಂಗಲ್ ಆಫ್ ಇನ್ಸಿಡೆನ್ಸ್ ಇದೆ, ಆಂಗಲ್ ಆಫ್ ರಿಫ್ಲೆಕ್ಷನ್ ಗೆ 90 ಡಿಗ್ರಿ ಇತ್ತಂದ್ರೆ, ಸೊ ಆಂಗಲ್ ಆಫ್ ಇನ್ಸಿಡೆನ್ಸ್ ಎಷ್ಟಿರುತ್ತೆ? 45 ಡಿಗ್ರಿ ಇರುತ್ತೆ. ಅದೇ ತರ ಆಂಗಲ್ ಆಫ್ ರಿಫ್ಲೆಕ್ಷನ್ ಎಷ್ಟಿರುತ್ತೆ? ಇಟ್ ಈಸ್ ಆಲ್ಸೋ 45 degree. So what is the angle of incidence of a ray if the reflected ray is at an angle of 90 to the incident ray? Option 90 degree, 60 degree, 45 degree, 180 degree. So answer is 45 degree. 45 degree is the answer. If the angle of incidence of light falling on a plane mirror is 30 degree, what is the angle of reflection? It is also 30 degree. When we stand in front of our dressing table, our left hand seems to be right and right seems to be left. This is called left-right confusion, lateral inversion, upside down phenomena, mirage. So when we stand in front of our dressing table, our left hand seems to be right and right hand seems to be left. This is called lateral inversion. So answer is the lateral inversion. If the light falls perpendicular on the plane mirror, what will be the angle in which it will be reflected? ಸಿ ಲೈಟ್ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಆಗಿತ್ತು ಅಂತಂದರೆ 90 ಡಿಗ್ರಿ ಫಾರ್ಮ್ ಆಯಿತು ಅಂದರೆ ಅದು ರಿಫ್ಲೆಕ್ಟೆಡ್ ಬೀಮ್ ಏನಾಗುತ್ತೆ ಅದೇ ಥರ ಸ್ಟ್ರೈಟ್ ಮೇಲೆ ಹೋಗುತ್ತೆ. ಸೊ ಆ್ಯಂಗಲ್ ಏನಾಯಿತು ಇನ್ಸಿಡೆಂಟ್ ರೇ ಮತ್ತು ರಿಫ್ಲೆಕ್ಟೆಡ್ ಬೋತ್ ಆರ್ ಕೋಇನ್ಸೈಡ್, ದೆನ್ ದ ಆ್ಯಂಗಲ್ ಈಸ್ 180 ಡಿಗ್ರಿ. If light falls perpendicular on a plane mirror, what will be the angle in which it will be reflected? So 45 degree, 90 degree, 180 degree, 360 degree. Answer is 180 degree. Which of the following is not a luminous object? Sun, candle, moon, tube light. Moon is not a luminous object. Answer is moon. To make a kaleidoscope, we require 3 plane mirrors, 4 plane mirrors, 3 plane glass sheets, 4 plane glass sheets. So, to make a kaleidoscope, we require 3 plane mirrors. 3 plane mirrors idre ನಾವು kaleidoscope ಅನ್ನು prepare ಮಾಡಬಹುದು. Which of the following will produce a regular reflection? Gold plate, steel plate, pearl, diamond, mirror. Which of the following will produce a regular reflection? Gold plate, not possible, irregular reflection. Steel plate, in this case also irregular reflection. Pearl, here also irregular reflection. So to get a regular reflection, we use mirror. So which of the following will produce a regular reflection? Mirror produces a regular reflection. Understand? So like this the questions comes. So many questions are there. We can discuss all the questions in the next class. And also you know the one more phenomena, that is eye and eye defect. Structure of eye. Eye ಕಣ್ಣಿನ ರಚನೆ ಹೇಗಿದೆ, ಆ ಕಣ್ಣಿನಲ್ಲಿ ಇರ್ತಕ್ಕಂಥ ಪಾರ್ಟ್ಸ್ ಯಾವುದು, ಅದಕ್ಕೆ ಸಂಬಂಧಪಟ್ಟಂತೆ ಕ್ವಶನ್ಸ್. ಐ ಡಿಫೆಕ್ಟ್ ಬರುತ್ತೆ, ಮಯೋಫಿಯಾ, ಹೈಪರ್ಮೆಟ್ರೋಫಿಯಾ, ಅಸ್ಟಿಗ್ಮ್ಯಾಟಿಸಮ್ ಅಂತಕ್ಕಂಥ ಡಿಸೀಸ್ ಇದೆ. ಅವುಗಳನ್ನು ಯಾವ ರೀತಿ ನಾವು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು, ಅದರ ಬೇಸ್ ಮೇಲೆ ಯಾವ ಥರ ಕ್ವಶನ್ಸ್ ಕೇಳ್ತಾರೆ ಅಂತಕ್ಕಂಥದ್ದು ನಾವು ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡೋಣ. ಓಕೆ, ಥ್ಯಾಂಕ್ ಯು ಫಾರ್ ವಾಚಿಂಗ್ ದ ಕ್ಲಾಸ್.